Solutions of partial differential equation. Before I start with the presentation, I will introduce you myself. I am Prijimol VB, working as an assistant professor in Christ College of Engineering, Irinyalakuda. You can find me at this email address. Instructions for use. Grab a piece of a paper and a pen with you. I recommend you to try solving these questions simultaneously as you watch the video. Go through the videos. Pause whenever you didn't understand a concept. Take your own time in processing the details. If still there is a difficulty in understanding, then please do reach me at this email address. Let's start with the first set of slides. Contents. At the end of the presentation, you will learn the types of solution and then how to solve a partial differential equation using direct integration. Solutions of a partial differential equation. The solution of the form f of x, y, z, a, b equal to 0 of a first order partial differential equation which contains two arbitrary constants say a and b is called a complete integral. After substituting particular values to the arbitrary constants, you get a particular integral. If you take a b as phi of a, that is a function of a, and find the envelope of family of surfaces, then we get a solution containing an arbitrary function phi which is called a general integral. The envelope of such family of surfaces with parameters a and b if exists is called a singular integral. Now what is the difference between particular integral and a singular integral? In particular integral, we just give particular values to the constants, but in singular integral we do not do so. Now let us solve some problems using direct integration. Solve dou square z by dou x square equal to xy. Now let us bring the right hand side to the left hand side. Now this is how the equation appears to be. Now if you closely watch, it is a second order partial differentiation. That means we have to integrate this equation with respect to x twice to eliminate the second order partial derivative with respect to x. Now let us integrate with respect to x, but please make sure when you are integrating with respect to x, y is kept as a constant. Now after this integration with respect to x once, this reduces to dou z by dou x. You know y is kept constant, and what is the integration of x? It is x square by 2. Since y is constant, anything related to y will be a constant. Now this is the integrating constant. Thus we got this equation. I am going to rewrite this equation in my next slide. Integrating again with respect to x, because we are left out with a first order partial derivative, that means we have to integrate again with respect to x to eliminate this partial derivative, and keeping y as constant, you will get z minus, since y is constant, y by 2 will be constant. What is the integration of x square? It is x cube by 3, and since f of y is constant, so constant into integration of 1 is x, and you had to add another integrating constant. Since y is constant, I will take a g of y as a integrating constant. Thus we get this as a answer. Now let us solve the next question. Solve dou cube z by dou x square dou y plus 18xy square plus sine 2x minus y equal to 0. We have rewritten the equation. Now if you carefully watch, it is a third order partial differential equation. That means we have to integrate twice with respect to x and once with respect to y to eliminate this partial derivatives. First, if you are integrating this with respect to x, the third order partial derivative becomes second order partial derivative, and since y is constant, 18 is constant, 18y square, integration of x will be x square by 2. I'll walk you through the steps. Sine of 2x minus y integration is minus cos of 2x minus y, and the coefficient of x must be divided, and you have to add an integrating constant. Since y is constant, I will take it as f of y. Thus we get this equation. Now integrating this again with respect to x, you will be left out with dou z by dou y. I have written this. You may follow the steps, but here g of y is another integrating constant. Now remember this, I am going to rewrite this equation in my next slide. Okay, now we are left out with only first order partial differential equation. Now to eliminate dou z by dou y, that is partial derivative dou by dou y, you have to integrate with respect to y keeping x as constant. So when you integrate with respect to x keeping x as integrate with respect to y keeping x as constant, this becomes z is x is constant, so 3x cube is constant, y cube by 3 minus 1 by 4, integration of sine is minus cos 2x minus y, and the coefficient of y must be divided, which is minus 1, equal to x is constant, but f of y is not constant. You have to integrate that again with respect to y. G of y is also not constant. Integrate that again. This g of y. Integrate that again with respect to y and add an integrating constant, say h of x, since x is constant. Thus we get this equation. Now since we don't know what is f of y and g of y, but we do know that after integration we get a function of y. Let us call this as u of y and even this as v of y. Okay, now replacing those as u of y and v of y, we get this equation. Now this is the solution of partial differential equation with the arbitrary functions u of y, v of y and h of x. Now let us solve next question. Solve dou square z by dou x dou y equal to sin x sin y, for which dou z by dou y is minus 2 sin y when x is 0 and when z is 0 when y is an odd multiple of pi by 2. Now let us rewrite the equation. Now if you carefully observe, it is a second order partial differential equation. That means you have to integrate once with respect to x and once with respect to y. You can choose any order of integration you like. You can first integrate with respect to y and then with respect to x, or integrate with respect to x and then with respect to y. It is your wish. You can do in any sort of manner you like. So here I am going to integrate with respect to x first, keeping y as constant. Now this is reduced to a first order derivative, say dou z by dou y. And y is constant, so sin y. What is the integration of sin x? It is minus cos x. Since y is constant, I can write f of y is a integrating constant. Thus we get this equation. Now we have to find out f of y, isn't it? But we do know the condition for dou z by dou y, that is when x is 0, dou z by dou y is minus 2 sin y. Let us substitute this condition in this equation. Okay, so after substituting dou z by dou y as minus 2 sin y, and what is the value of x? X is 0, so cos 0 is 1, so minus sin y plus f of y. After simplifying this, you will be getting this equation. F of y is minus sin y. Now I have written the equation from the previous slide. What was our equation? Equation 1 is this. Substitute f of y as minus sin y. So you get a first order differential equation. That means you have to actually solve this again, that is integrate this again with respect to y, keeping x as constant. So when you integrate this again with respect to y, you will be left out with z equal to, so minus cos x sin y, integration is again minus cos y, minus of minus cos y, and you have to add an integrating constant. X is a constant when you are integrating with respect to y. So let us add an integrating constant as g of x. Because I have used f here, I am using g here, g of x. Thus we get this equation. Now remember this equation. Now after finding g of x and then replacing here, then we will get our solution, required solution. But to find g of x, we may have to use the second set of conditions. Remember this equation very well. I am rewriting that equation. So your z was cos x cos y plus cos y plus g of x. This was our equation. We have to find our g of x. This is our primary aim. Now, you know y is an odd multiple of pi by 2. That means put z as 0 and y as any odd multiple of pi by 2. Now after replacing this, z is 0 and cos pi by 2 is also 0. You will get g of x as 0. So substitute g of x as 0 in this equation. So you will get a complete solution. This will be your answer. Since we are getting a complete solution without any arbitrary constants or arbitrary functions. Now let us move on solving to the next question. Solve dou square z by dou x square plus z equal to 0 given that when x is 0, we have two conditions satisfied. Z is equal to e raised to y and dou z by dou x equal to 1. Now let us rewrite the equation. If you may observe, it is a second order partial derivative, but we can see only one independent variable here, x. That means you can rewrite this partial differential equation as an ordinary differential equation. Say you can write it as d square z by dx square plus z equal to 0, which can be written as d square plus 1 of z equal to 0. Now this is a homogeneous second order differential equation with the constant coefficients. This can be solved by writing the auxiliary equation, which is m square plus 1 equal to 0. Now after solving this equation, you get the roots as plus or minus I, which are the purely imaginary roots. Now the solution of such a differential equation is z equal to a cos x plus b sin x, where a and b are constants. But we actually know z is actually a function of x and y, isn't it? But in our differential equation, we find only x as independent. That means y must be treated as a constant. Now let us take a and let us take b as functions of y, since y is treated as constant. So I have taken f of y cos x plus g of y sin x. In the place of a and b, we have taken f of y and g of y. Now let us substitute the conditions. This is our primary set of conditions. Put x as 0 and z as e raised to y in this equation. So you will get e raised to y. Z is e raised to y, x is 0, cos 0 is 1. So f of y plus sin 0 is 0. So you get f of y as e raised to y. Now substitute f of y as e raised to y in this equation. So after substituting, you get this. Now our next goal is to find out what is g of y. But I hope you remember the second set of conditions was dou z by dou x. That means you have to differentiate this again partially with respect to x. Now after differentiating that equation, you get this. Now let us substitute the condition. Put x as 0 and dou z by dou x as 1. So you will get 1 is equal to minus e raised to y sin 0 is 0 plus g of y cos 0 is 1. Thus we get g of y is 1. Let us substitute that in our previous equation in the previous slide. Thus we get this as a desired solution. Coming up next, we will be discussing what is Lagrange PDE, how to solve Lagrange PDE, and then how to solve the partial differential equation using methods of separation of variables, and then how to solve nonlinear partial differential equation using Charpit's method. Thanks for watching. If you have any questions, please do mail me at this email address. and a special thanks to all the people who made and released these awesome resources for free. Like these templates are made available by Slides Carnival and the photographs by Unsplash. I hope you have understood whatever is being taught in today's presentation. Keep watching remaining videos which I will upload in my channel. Thank you.